That means that the simplest picture of the universe is a universe that's infinite. We really could live in a universe where there's galaxy after galaxy after galaxy in every direction, up, down, sideways, and it never stops.
How big is our universe? Is it endless or infinite? What's its diameter? These questions have fascinated scientists for centuries. But thanks to the James Webb Telescope, we can now look back in time and explore the vastness of the cosmos to find some answers.
There's something else there. There's something beyond the galaxies that we see, the visible matter.
By peering billions of years into the past, the James Webb Telescope has given us glimpses into how the universe came into existence, and has shown us where it ends and what lies at its edge. But discoveries made by this telescope have shocked scientists as they challenge some of the fundamental laws of physics. Let's explore the vastness of the cosmos, delving into its immense expanse and uncovering its boundless wonders.
At the end, we concluded that actually the universe really isn't slowing down. It's actually speeding up in its expansion. And that was a big shock.
The vastness of the universe is truly mind-boggling. The sun, that bright fiery orb that lights up our days and warms our planet, is actually quite far away from us. It sits at a mind-boggling distance of about 149.6 million kilometers or 92.9 million miles. To make it easier to understand such a vast expanse, scientists came up with a unit of measurement called an astronomical unit, or AU. 1 AU is roughly equal to 149,598,000 kilometers, or 92,955,887 miles. Now, let's try to wrap our heads around this immense size of the entire universe. Scientists believe that the universe stretches about 93 billion light-years across. But what exactly is a light-year? Well, it's the distance that light can travel in 1 year. Surprisingly, a single light-year is equivalent to a whopping 63,000 astronomical units. When we consider that each light-year measures an incredible 9 trillion kilometers or 6 trillion miles, we start to grasp just how vast the universe truly is. But wait, there's more. The number I just mentioned, the 93 billion light-years, represents only what we can currently observe of the universe. It's just a fraction, the part that our instruments and technologies have allowed us to see. Scientists believe that the entire universe could be a staggering 250 times larger than what we can currently perceive. This means that the universe itself might have a diameter of at least 7 trillion light-years. To truly appreciate the magnitude of this vastness, let's think about traveling through space at the speed of light. Light itself moves incredibly fast, zooming through space at about 299,792 kilometers per second, or 186,282 miles per second. At this astonishing speed, light can cover the distance from Earth to the Sun, 1 astronomical unit, in just 8 minutes and 20 seconds. If we apply this incredible pace to cross a single light-year, it would take approximately 9 trillion kilometers or 6 trillion miles and an entire year for light to complete its journey. Now imagine for a moment the space probes Voyager 1 and Voyager 2. These brave explorers launched back in 1977, having traveled farther into the universe than any other human-made objects before them. They have reached distances of about 23 billion kilometers, or 14 billion miles from Earth. To put their achievement into perspective, let's compare their speed to that of light. Voyager 1 is zooming through space at around 61,000 kilometers per hour, or 38,000 miles per hour. Voyager 2 maintains a slightly slower pace, clocking in at approximately 55,000 kilometers per hour or 34,000 miles per hour. While their speeds may sound impressive to us, they're just actually a tiny fraction of the speed of light, which means their current progress is quite small in comparison. Now let's think about the challenge of reaching the nearest star system beyond our Sun, which is relatively close in cosmic terms. Proxima Centauri, a small red dwarf star, is located approximately 4.24 light-years away from our solar system. If we could travel at the incredible speed of light, it would take us about 4.24 years to reach this neighboring star system. However, considering the speeds of our intrepid Voyager spacecraft, It would take them an estimated 70,000 years to cover the same distance. The difference between their velocity and that of light becomes quite apparent, underscoring the vastness of the universe and the difficulties of interstellar travel. As we delve deeper into the vastness of space, we're greeted by the enchanting constellations, patterns of stars that adorn the night sky. These celestial artworks have fascinated humanity for centuries, guiding our eyes and sparking our imagination. One constellation that leaves us in awe is Hydra, the largest of the 88 recognized constellations. Spanning over 100 degrees in the night sky, Hydra stretches across the celestial sphere, hosting a multitude of stars within its vast domain. Among them, the brightest is Alphard, a splendid orange star residing approximately 177 light-years away. Just imagine the sheer scale of Hydra, its sprawling presence, and the countless stars within it, each one holding a story of its own. Moving on, we come across the captivating Centaurus constellation, renowned for its striking asterism known as the Southern Cross. Centaurus not only captivates our eyes, but also harbors celestial wonders within its boundaries. Nestled within this constellation is Alpha Centauri, a triple star system comprising of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A and B elegantly dance around each other, forming a binary pair, while Proxima Centauri, situated about 4.24 light-years away, claims the title of our closest known stellar neighbor. While these stars may appear relatively close compared to their vastness in the universe, they still reside at vast distances, underscoring the grand scale at which celestial bodies exist. Continuing our celestial odyssey, we encounter the mythical Andromeda constellation, named after the legendary princess in Greek mythology. Within Andromeda lies the famed Andromeda Galaxy, known as Messier 31 or M31. This colossal spiral galaxy is a sight to behold, located an astonishing 2.537 million light-years away. Spanning a majestic diameter of about 220,000 light-years, it's estimated to host a mind-blowing 1 trillion stars. Contemplating the sheer number of stars within a single galaxy fills us with wonder and reminds us of the unfathomable vastness of the cosmos. But let's not forget about our very own cosmic home, the Milky Way. Our splendid galaxy boasts a magnificent spiral structure stretching about 100,000 light-years in diameter. Within its graceful arms, uncountable stars twinkle, contributing to the resplendent beauty that graces our night sky. Scientists estimate that the Milky Way is home to an astonishing 200 to 400 billion stars. These numbers are truly staggering, further emphasizing the incomprehensible vastness of our galactic neighborhood. Now, as we venture beyond the borders of our own galaxy, we encounter other major galaxies that populate the cosmos. One such gem is the Triangulum Galaxy, also known as Messier 33 or M33. It stands as the third largest member of the local group, a collection of galaxies that includes the Milky Way and the Andromeda Galaxy. Situated approximately 3 million light-years away, the Triangulum Galaxy spans a diameter of around 60,000 light-years and contains an estimated 40 billion stars. Its delicate arms extend gracefully across the cosmic void, captivating astronomers and stargazers alike with its celestial poetry. Moving deeper into the universe, we come across the Whirlpool Galaxy, also known as Messier 51 or M51. This captivating beauty is located around 23 million light-years away and showcases a fascinating interaction between two galaxies. Its spiral arms wind around a companion galaxy, creating a mesmerizing dance of gravity. The Whirlpool Galaxy spans a remarkable 60,000 light-years and dazzles us with its radiant splendor. Another stunning sight is the Sombrero Galaxy, or Messier 104, situated approximately 29.3 million light-years away. This galaxy earned its name due to its resemblance to a wide-brimmed Mexican hat. With a diameter of about 50,000 light-years, It features a prominent bulge at its center, surrounded by a distinct dust disk that gives it its unique appearance. And let's not forget about the magnificent Pinwheel Galaxy, also known as Messier 101. Located around 21 million light-years from us, this spiral galaxy boasts an impressive diameter of 170,000 light-years. Its spiral arms, adorned with countless stars, create a captivating tapestry that beckons us to explore its mysteries. These examples are just a glimpse of the breathtaking galaxies that populate our universe. Countless others exist, each with its own distinctive characteristics, composition, and distance from us. Our universe is a vast and awe-inspiring place, brimming with cosmic wonders that surpass our wildest imaginations. As we gaze up at the night sky, we're reminded of our humble place within this grand tapestry of stars and galaxies. The sheer vastness of the cosmos humbles us, inspiring us to seek knowledge and marvel at the beauty that surrounds us. We are but tiny specks in this immense cosmic dance, witnesses to the magnificence that stretches across unimaginable distances. To put these distances into perspective, let us consider the speed of light, which travels at an astonishing 299,792 kilometers per second. As we've discussed, the star Alphard in the Hydra constellation, mentioned earlier, is situated roughly 177 light-years away. If we were able to travel at the speed of light, it would take us a staggering 177 years to reach Alphard. Can you imagine that you would spend nearly 2 centuries in transit just to reach a single star within a constellation? Moving further, the Alpha Centauri star system, the closest to our own solar system, is located approximately 4.24 light-years away. Traveling at the speed of light, it would still take us over 4 years to reach Alpha Centauri. In contrast, the Andromeda Galaxy resides at a mind-boggling distance of approximately 2.537 million light-years away. Traveling at the speed of light, it would still take us over 2.5 million years to reach this galaxy. To put this into perspective, consider that the entire existence of the human species as we know it spans roughly 200,000 years. Even if we could travel at the speed of light, it would take us more than 12 times the entirety of human history just to reach a single galaxy. Contemplating these vast distances, we realize that our cosmic neighborhood is but a tiny fraction of the universe. The observable universe is estimated to have a diameter of 93 billion light-years. This means that even the farthest galaxies we can detect are still within this relatively small bubble of space. The immensity of the universe, with its countless galaxies, stars, and planets, truly transcends our comprehension. Now, you may be wondering why the universe is so incredibly vast. Well, the answer lies in the fact that the universe is constantly expanding. In fact, it's expanding at a rate that surpasses even the speed of light. It's not objects within the universe moving away from each other, but rather space itself stretching and growing. This expansion has been happening for roughly 14 billion years, and it continues to this very day. Now, as to why the universe is this large, we don't have a definitive answer. It's a question that baffles scientists and philosophers alike. One thing to consider is our own perception. Think about how small you are compared to an ant or an atom. The difference is enormous. Similarly, our perception of the universe is vastly limited, even in our modern age. In the past, our ancestors didn't have the luxuries of cars or planes. They would embark on long, arduous journeys that could take months or even years to reach their destinations. To them, the Earth must have seemed impossibly vast. But with the advancements in technology, the world has become so much smaller. We can now travel from one point to another in a matter of minutes, hours, or at the most, a few days. Our perception of size has changed drastically. Now the question is this universe truly infinite? It's a question that's baffled scientists and philosophers alike, and it continues to ignite curiosity and spark debates. We often hear that our universe is around 13.8 billion years old, but the exact age is still uncertain. In fact, sometimes we struggle to determine the age of objects right here on Earth, let alone the vast expanse of the universe. When we consider the sheer number of stars and planets, along with the mind-boggling distances between them, and the fact that our universe is continuously expanding, it seems plausible that it could be infinite. The idea of an infinite universe is not far-fetched, given its incomprehensible vastness and the unimaginable amount of time it would take to explore everything within it. Our perception plays tricks on us, making it difficult to truly grasp the true nature of the universe. If we look around our world, we can notice a pattern of duality: day and night, hot and cold, love and hate. Everything within our little sphere seems finite, so it's not a stretch to imagine that there might be an infinite element, such as our universe. Many people are hesitant to accept the idea of something being infinite, as it goes against our everyday experiences. However, even if we were to reach the supposed end of the universe, it would still feel infinite to us, given its vastness and our limited understanding. So, does the universe have an end? Well, many cosmologists argue that the universe is flat and will continue expanding indefinitely.
If the universe were positively curved, if the angles inside the triangle added up to greater than 180 degrees, then it would be finite in size. If the spatial geometry is flat, if the angles inside the triangle add up to 180, then it could go on forever.
According to this view, galaxies and other celestial objects will keep moving away from each other, driven by the force of the initial Big Bang. This perspective suggests that the universe will never reach an ultimate conclusion or end. However, other theories propose different scenarios. One possibility is that the universe will ultimately cease to exist when all the stars reach the end of their lifespans, resulting in a desolate cosmic landscape devoid of light and energy. This hypothetical fate is often referred to as the Big Freeze. Alternately, the expansion of the universe might halt, leading to a reversal and an eventual collapse, followed by a new beginning with another Big Bang, a concept known as the Big Crunch. A third theory, the Big Rip, suggests that everything, even atoms, would be torn apart as dark energy overcomes gravity. These apocalyptic scenarios, however, are not expected to occur for billions of years, and they're still highly speculative. Where does space end? This question is challenging to answer definitively because space itself is constantly expanding, surpassing even the speed of light. From our perspective, space seems to conclude at approximately 93 billion light-years away, known as the observable universe. However, this limit represents the farthest that we can currently see, and is not necessarily the ultimate end of the universe. It's merely the boundary of our observational capabilities. Will the universe last forever? That's a mystery we're still far from unraveling. It's possible that the universe will continue expanding indefinitely, but by the time any potential end occurs, humanity might no longer exist to witness it. We currently lack knowledge of whether the universe will eventually stop expanding and what that would mean for its fate. The concept of time and existence becomes increasingly complex when considering the vast timescales and the potential evolution of the universe. Many doomsday scenarios have been proposed, as mentioned earlier, but perhaps that's simply a reflection of our nature. As sentient beings, we're prone to ponder our own mortality and the ultimate fate of the cosmos. The universe may very well have an eternal lifespan, with the expansion and contraction cycles perpetuating indefinitely. However, one thing is certain: we have a long way to go before we can confidently answer such profound questions about the nature of our universe. As everything in the universe is in constant motion, we observe that many celestial objects, such as galaxies, are moving away from us. This phenomenon, known as the expansion of the universe, suggests that the fabric of space itself is stretching. Perhaps this continuous expansion is the true end of the universe, when everything becomes so far apart that it's beyond our reach, and the concept of the universe itself becomes indistinguishable. At that point, everything will be so distant that we may not even realize it exists. The fate and ultimate boundaries of the universe remain an enigma, and we are merely voyagers in its unfathomable expanse, exploring and contemplating our place within it. As humans, we're driven by curiosity and a desire to understand the world around us. We strive to unravel the mysteries of the universe, to comprehend its vastness and our significance within it. Throughout history, humanity has made remarkable discoveries and advancements in our understanding of the cosmos. From ancient civilizations observing the movements of celestial bodies to the development of powerful telescopes and space probes, we've come a long way in our exploration of the universe. Yet, with each answer we uncover, new questions arise, pushing the boundaries of our knowledge further. The concept of infinity is both intriguing and confounding. The notion of an infinite universe challenges our intuition, as we're accustomed to experiencing finite things in our everyday lives. We observe beginnings and endings, birth and death, and the cyclical nature of existence. The concept of something eternal and boundless, like the universe, stretches our imagination. If the universe were indeed infinite, it would mean that its expanse knows no bounds. It would continue to expand and evolve, potentially giving rise to an infinite number of galaxies, stars, and planets. Such a notion is awe-inspiring, for it implies the existence of an unimaginable number of worlds, each with its own unique characteristics and possibilities. However, the idea of infinity also presents philosophical and scientific challenges. Can something truly be infinite? Does it defy the laws of physics? These questions remind us of the limitations of our understanding and the vastness of the mysteries that lie beyond our grasp. In the pursuit of knowledge, scientists and cosmologists have developed various theories about the nature and destiny of the universe. These theories are based on observations, mathematical models, and our current understanding of fundamental forces and particles. Each theory offers a glimpse into the possible outcomes for our universe, but they remain speculative and subject to further exploration and refinement. One of the prevailing theories is that the universe will continue to expand indefinitely. This theory suggests that the forces propelling the expansion, often referred to as dark energy, will overpower the gravitational pull between celestial objects. As a result, galaxies will move further apart, stars will burn out, and the universe will gradually become a vast, cold expanse, devoid of the energy necessary to sustain life. Another theory proposes a cyclical nature to the universe, with expansion followed by contraction. According to this concept, the universe goes through cycles of expansion, followed by a collapse known as the Big Crunch. After the collapse, a new cycle begins with another Big Bang, leading to a fresh expansion. This theory suggests that the universe is in a constant state of renewal, and that it has experienced numerous cycles throughout its existence. Thanks so much for watching this video. Don't forget to let us know your thoughts in the comment section below.